Hey guys, it's a little smoky today. This is Tuesday, and we're going to be going on to the next section in our lecture and take care of a little bit of lecture notes while things are in this condition, while we're doing this digital learning. So please include this in your notebooks. This is going to be section 3.1. We're going to be looking at acceleration. We've previously been looking at velocity and a little bit at acceleration now, but this is going to be focusing more on acceleration. So if you can sketch an XY axis to start off with, like this. But now we're looking at velocity in time. Previously we've been looking at dt graphs, now I'm going to be focusing on vt graphs. Okay, so let's take a look at three possible scenarios. So scenario number one, or scenario A, we have scenario B going up like this, and scenario C. They do not need to intersect. This is just showing the slopes. So just as we take the slope of a dt graph to get velocity, we can take the slope of a vt graph to get acceleration. The reason is because if you take the slope again is the change in y over the change in x. The change of y is my velocity, so it's going to be my change in velocity. My change in x is my change in t. So my change in velocity per my change in time, this is equal to my acceleration. Notice that each of these scenarios, A, B, and C, they're all linear. So A, what's the slope of A? Take the slope of A is 0. So that means my acceleration must equal 0. If my acceleration is equal to 0, that means it's neither speeding up nor slowing down, so this is going to be constant velocity. Taking a look at the slope of B, my slope is positive, so I will have acceleration. So this is constant motion, this is non-uniform motion. My velocity is changing. And also, if I take a slope of C, my acceleration will be negative, or I'll have deceleration. So this is constant motion, and therefore the others are going to be non-uniform motion. So B and C, this is an example or examples of non-uniform motion. So we're going to have an example of a skydiver jumping out of an airplane. We can draw an XY axis again, looking at something like this. Here's my velocity, and here's my time. Okay. Later, we're going to be getting into motion in two directions, because if you can imagine, your airplane is flying, and it's flying in a forward motion. So we're flying in the X direction, on the x-axis, and this is not changing. Okay. However, the velocity is staying the same. However, we're going to jump out of the airplane, and that jumper will look something like this. Okay. So when the jumper first starts out of the airplane, in terms of the up and down direction, the vertical direction, when they're standing in the airplane, they have a 0 velocity, meaning they're traveling in the airplane like this, yes, but in this direction, they have a 0 velocity. So in the x direction, they have constant motion because that's the velocity of the airplane, but in the y direction is going to be 0 until they jump out. So they're going to jump out, and they're going to then obtain a velocity. Okay, what's going to happen to their speed? Okay, their speed's going to increase. It's going to get faster and faster and faster. But then something interesting is going to happen. They're going to reach what's called terminal velocity. So this is what their velocity is going to look like, okay? I first jump out at point A, and that means I'm getting faster, okay? But then I'm going to be continuing to point B, and it might be right here. So here's point, we'll just say point 1, and here it's going to be point 2. However, what's going to happen is we're going to be slowing down our increase in velocity, meaning that at first my velocity is going to increase very rapidly, okay? But then it's going to slow down a little bit, and then it's going to slow down greatly, and it might look something like this. So here's 3, and then here will be number 4. Jump out of the airplane, goes very, very fast, okay? Now, think of this, you're going on a freeway. You're on the on-ramp, okay? Where do you increase the velocity the fastest? You increase the velocity the fastest right when you start, because you're going from 0 to some type of velocity. You're increasing your velocity the fastest. When you're finally at your 60 miles per hour, you're traveling at a constant velocity. So notice how your velocity is not changing. So this is a skydiver. This could also be representative of a person driving onto a freeway. Now we're at our top speed. And if you're falling in the sky, what's happening is that right here at this point, you've reached what's called terminal velocity, meaning you can't go any faster than that. We'll talk about terminal velocity a little bit later. So what is going to be my velocity or my acceleration actually at each of these points in time? Well, just as we had a dt graph and we can take the instantaneous velocity, we can have a vt graph and we can take the instantaneous acceleration. So if I take the slope of this line here, the slope of this line here, remember this is the slope to the tangent, and it can only go through the point once. We have that slope there, and then we have this right there. Okay, so if we're taking a look at these slopes, okay, we're going to take a look at 1, 2, 3, and 4. We're going to be looking at the instantaneous acceleration. And again, that is obtained by taking the slope of the tangent. Okay, so slope number 1, this is going to be the steepest. This is where we are gaining velocity the fastest. It's harder to gain velocity up here if you're driving up on-ramp on a freeway. Harder to gain more velocity. Now we're at my top speed. I'm not gaining any velocity. So this is the steepest, and therefore this is going to be the highest acceleration. Number 2 is going to be less steep. Less steep. Number 3 is less steep. And then what's the slope of 4? Slope of 4 is 0. So what that means is my velocity is constant. If I take the slope of that, again, a 0 slope means my acceleration is going to be equal to 0. So in all these cases, 1, 2, and 3, these are all going to be, acceleration is going to be positive. I have positive acceleration. However, right here, this is a higher acceleration. Number 1 has a higher or a larger acceleration because the slope is going to be more. What that means is my velocity is increasing more every second. Okay, look at number 3, very shallow slope. Okay, this means I have a lower acceleration. Now my velocity is still increasing, but it is increasing at a slower and slower rate. So it's going to apply to a skydiver, or it can also be going on an on-ramp as well. Okay. Okay, if you can go to your next page, we're going to be taking a look at vectors. This previous section, we won't title that, but this is going to be taking a look at vectors. So it's the same section. And imagine you're on or at a stoplight. Okay, you're stopped. And you're now going to increase your speed. So we can draw a couple of these vectors. This one's going to be a little bit larger. This one's going to be a little bit larger. Same size. A little bit smaller. And then smaller, then coming to a stop. These are going to be my velocity vectors. We need to define our coordinate system. So it's going to be my negative direction and my positive direction. When we're looking at the velocity that we start off as is going to be 2 meters per second. Here's 4 meters per second. Then 6 meters per second, etc. 6 meters per second. Going backwards now, 4 meters per second, then 2 meters per second. So I'm speeding up, which indicates the size of the arrow, going at a constant speed, then I'm slowing down, coming back to a stop. So this section is looking at acceleration, so let's go ahead and calculate the acceleration. Acceleration again, and this is the average acceleration. This is going to be the change in velocity over the change in time. Now to remind you that the change in velocity, this is my v1 minus my v0, okay, over the change in time. We're not going to worry about the change in time because we're not going to be calculating exact things here. However, if you remember with vectors, we really can't subtract vectors, we add the opposite vector. So this really means that we have a v1 plus a negative v0. So let's take a look and see what is happening between here and here and between here and here. So let's say that this is my v1 here and this is my v0. And I want to find out what's my acceleration. So if I draw my vector is going to be 4 meters per second. Okay, and I'm going to add this vector to it, but remember, we're going to be adding the vector in the opposite direction. So it's a negative v0. And the rule is that we take the tail of the second and add it to the head of the first. And so we're going back in the opposite direction, okay, and that's going to be 2 meters per second, and this is going to be 4 meters per second. What's my acceleration? My acceleration is the resultant, and my resultant looks like this. Okay, so my resultant will then be 2 meters per second. So when I subtract those, okay, or add them, 4 plus a negative 2, this will give me 4 meters per second squared. Or 2 meters per second squared. Okay, so my acceleration will equal, if this is per second, it's going to be 2 meters per second squared. That's my resultant. Okay, what happens if I go from here to here? What's my acceleration? Well, I have 6 plus a negative 6. My acceleration here, we're not going to draw the vectors. Well, actually we could. So we have a 6 in this direction, we have a 6 in this direction. Therefore, my resultant is going to be 0. So my acceleration is going to be 0 meters per second squared. What happens, though, when I go here? Remember, this is my initial, this is going to be my final, V0 and V1. So I'm going to be taking my final, which is going to be 2 meters per second, So I have 2 meters per second like this. Okay, 2 meters per second. And I'm adding a negative 4 meters per second. So my resultant is going to be this here. That's my acceleration. But notice how my acceleration is now pointing in the negative direction. My acceleration will be negative 2 meters per second squared. So when you're going in the positive direction, if you're increasing your velocity, you're going to have a positive acceleration. If your velocity is not changing, you're going to have zero acceleration. If your velocity is decreasing, you'll have negative acceleration. But let's say that we now stopped, and now we're going to move backwards in the negative direction. Okay, so let's draw what this would look like. 2, 4, 6, 6, 4, then 2. Coming back to a stop again. So now, again, our coordinate system, this is my positive, this is my negative. What's happening is I'm moving in the negative direction. When I move in the negative direction, my velocity is now negative. So this is actually negative 2 meters per second, negative 4 meters per second, negative 6 meters per second, negative 6 meters per second, negative 4, and then negative 2 meters per second, then coming to a stop. So let's calculate now my accelerations. Okay, what's happening here is I have a v1 minus v0. So here's my v0 and here's my v1. Okay, if I'm taking my delta v, okay, which is going to be part of my acceleration, okay, my delta v, again, it's equal to the v1 minus the v0. So my v1 is actually going to be negative 4 minus my v0, which is negative 2. So this will be negative 4 plus positive 2, which is going to be equal to negative 2 meters per second. When I plug this in here, if it's per 1 second, my acceleration then is going to be equal to negative 2 meters per second squared. What will happen here? Again, v1 minus v0, this will give me an acceleration of 0 meters per second squared. Let's take a look at what's going to happen with the velocity vectors up here. Okay, here's my v0, here's my v1. Again, the formula is v1 minus v0. My v1 is going to be a negative 2 minus the v0. v0 is going to be negative 4. Becomes plus positive. So my change in velocity is going to be equal to positive 2 meters per second. And if this is happening in 1 second, my acceleration will be 2 meters per second squared. So let's take a look at this scenario and compare it to the previous scenario. When I increase my speed, and I'm starting off going in the positive direction, I have a positive acceleration. When I decrease my speed in the positive direction, I have a negative acceleration. Over here is kind of tricky. I am increasing my speed in the negative direction, I have a negative acceleration. And in order to stop, I have a positive acceleration. Now, think of this in terms of forces. Over here, you're stopped. Here's positive. How do I get my stopped car rolling? I have to apply a positive force to move me in this direction. Now I'm moving at 6 meters per second. What type of force do I need to slow me down? I need a force in the opposite direction to slow me down. So therefore I have to have a negative force. Likewise down here, I'm stopped. What's going to get me going? I need a force in which direction? The negative direction. Therefore, I need to have negative acceleration. Now that I'm traveling in the negative direction, what's going to stop me? A force in the positive direction. Therefore, I have positive acceleration. So let's summarize all of this, speeding up and slowing down. So when we speed up, if you have velocity that's going in the positive direction and acceleration in the positive direction, that's what we have here. We're going the positive direction, velocity and acceleration. We're going to be speeding up. Where else will I be speeding up? I'll also be speeding up when I have velocity that's going in the negative direction and acceleration that's going in the negative direction. Where do I find that? That's where I'm right here. So to speed up, I have to have a negative velocity going in the negative direction. My acceleration also has to be negative. This is showing that when your signs are in the same direction, you're going to be speeding up. How do you slow down? You slow down when your acceleration, your velocity are in opposite directions, or your velocity and your forces are in opposite directions. So if I have a velocity, okay, if I have velocity that is going in the positive direction, and I have acceleration that's going in the negative direction, where is that going to occur? Velocity in the positive direction, acceleration is going to be in the negative direction. I'm going to slow down and come to a stop. Okay, if I have my velocity that's actually now going in the negative direction, so I'm going in the negative direction, what's going to slow me down? Okay, an acceleration in the positive direction will then slow me down. So here, on this side again, the velocity and the acceleration are in the same direction. Here we have the velocity and acceleration are in opposite directions. Okay, so just a key to this is that the sign of the acceleration alone does not tell you if you're speeding up or slowing down, okay? Because we have positive acceleration here, we're speeding up. We have positive acceleration here, we're slowing down. So that's just kind of a key point. The sign of my acceleration alone doesn't tell if speeding up or slowing down. You need to also know what's happening with your velocity and the direction that you're traveling, whether you're going to be speeding up or slowing down. This is also going to be applied to elevators, moving up an elevator, moving down an elevator with positive acceleration and negative acceleration. That is it for today. Hopefully we'll see you guys soon.